Today we're going to solve another problem. This problem was given in the Olympiad of Russia and it's a very interesting problem. Uh, Nothing is given in a triangle and he's asking for the area. Let's see if you can solve this problem. In this particular problem, the only thing we know is the perimeter of this triangle is minimum and angle B is 2 times angle C. He's asking for the area of the triangle. First, I want you to pause the video and see if you can solve the problem yourself. If you couldn't solve it, I will solve it for you. So in here, the first thing which we do, we know B is equal to 2C. So we draw the bisector of this angle, and naturally, if this angle is alpha, angle DCB, if that is equal to alpha, angle DBC would be alpha also because B was 2 times angle C. So we have a situation like this. Now notice that angle BDA is the external angle of BDC and it becomes 2 alpha. If you observe this figure very carefully, you will see triangle ABD similar to ABC because in ABD we have two angles of alpha and 2 alpha. In an angle ABC we have two angles of alpha and 2 alpha as well. The angle C is alpha and B is 2 alpha. So if we assume the length of DC is equal to x, AD is going to be B minus x, and since these two triangles are similar with each other, I can write this relation of AD over AB equal to AB over AC equal to BD over BC. We knew AD is B minus x and AB is equal to C. So we have such relationship, and from this relation, we can easily show that B minus x over C equal to x over A, and we come up with this relation, you see, and finally we get B times B equals C times C plus A. This is a very important relationship we come up with. Now, we start giving the number. We assume that in here B is equal to 1. If B first is equal to 1, which is the length of the triangle, it is impossible because it was told in the problem they are all natural numbers, and it is possible 1 become 2 C plus A. So it has no answer. If B is equal to 2, then B square is equal to 4, and the only possible case would be C equal to 1, and C plus 1 is equal to 4. But remember, two sides of the triangle is always greater than one side, and such a relationship, let's see if is possible or not. 1 plus 3 become equal to 4 is not greater than 4, so this relation is void also. The third situation is if B equal to 3. If B equal to 3, B squared would be equal to 9, and since C plus A B become 9, and the least thing which we can have, C is equal to 1, and from there if C equal to 1, A become 8, and again 8 plus 1 is not going to be greater than 9, it's going to be equal to 9, so that case is also gone. The fourth case is when B is equal to 4, then B squared is equal to 16, and we have the exact same situation. C plus A, C in this relation, the least thing, the case which we can have is C equal to 1. If C equal to 1, then C plus A has to be 16, and C become 15. 1 plus 15 can't be equal to 16, has to be greater than that. So this relation is also gone. Another thing which we can have is 2c is equal to 2, then c plus 1 is equal to 8, and a becomes 6 because c plus a become 8. 2 minus 8 is 6, c is equal to 6. And again in here 6 plus 2 has to be greater than 8, and it is impossible. The next case is 5, and for same reason 5 is declined also. So let's select 6. If we select 6, the first case is c equal to 1, and for similar reason it is declined. The second case 2, the similar reason a becomes 16. 16 plus 2 is equal to 18. C plus a is equal to 18, and that is impossible also because simply this relationship does not work. The next case is if we have 6 and 6, and they are all declined. The only case which is accepted is the last case, 6. If you kill 6, c might become 4, and c plus a might become 9. Then from here, a is equal to 3. And then that could be accepted, and that is the only situation which is accepted if we have the sides of this triangle is equal to 5 and 4 and 6, 5, 4, and 6, then this is the only situation which is accepted. Now notice in here, if b equal to 8 or more, then b plus c is greater than b in a triangle, and this tells us that parameter is not going to be minimum. So the only accepted case in this case is when b equal to 6, c 4, and a equal to 5. So these are the sides of the triangle we are looking for, 4, 5, 6, where the parameter is minimum and b greater than b equal to 2c. Thank you very much for watching our video. I'm Dr. Jahanian, and if you like our problems, I invite you to subscribe our channel, and you'll be the first one to receive our next problem. Thank you very much.